All right, what I'm going to show you today is meshing this bushing from our recent webinar. First thing I'm going to do is I've already downloaded some files, and I like to set my working directory. So I'm going to choose File, Set Directory, and I'm going to make sure that I choose, this is the directory where I was running the webinar from. I could click the little three dots and choose that directory if I wanted to. And when I hit OK, we'll notice that my working directory in the bottom here will now update with my full directory path. So that's what I was looking for here, was for this to change. So let's go ahead now. So now if I do a file import, I'm right in that working directory. I can import this ACES file. Again, if it's a different format, I could choose a different CAD format to open. So go ahead and open that. Okay, and now I've got my geometry loaded here. One of the things I like to do first is I like to assign blocks to each individual part. So I'll start with my command panel, choosing block assignments. I want a new block. This is block 1. Maybe the name is the bushing. And it's going to be volume 1. So I'm going to click that and hit apply. Now, one of the things I always do, and I showed a little bit here just to try to go around that, is you'll notice that every single one of these commands that I've been running, from the importing to adding the block, I've been running some commands, or commands have been running for each of those actions. I can identify those by clicking on the history tab, and I've got a history here. And what I use this for is my personal environment is to have a journal editor open. I have a second screen to the right of this one, and in practice, I will just throw my journal editor over to that other screen, so that then I can have a full window here that I can process with Cubit. And I may do that at points today, but I'm going to try to at least start off by showing these side by side. And then what you'll do, or what I do, is I will then copy commands that have run, and I will be pasting them into my journal file. Something else that is also a command that gets run is, like this little reset. So if I hit new, that's a little reset command. And obviously this isn't the order at which I want to rerun things, but once I copy them over to a journal file, say I can copy this reset command, and I can place this where I want. And so now I can start to kind of build up a journal file. It's not critically important for a journal file for me to have this change directory command if I don't want. So anyways, I just start kind of building up my journal file from here. And I know that one of the things I want to do first, so this is kind of like import CAD. Again, in the Cubit journal language, or Cubit command language, pound symbols are comments. And so I can say maybe here, assign blocks. And I can, if I select multiple things, I can right click and say play selected to play just portions of my journal file. And what I kind of can see here is like, oh, okay, I kind of know how this command is going to work. So I can duplicate this a few times, and I can say, okay, well, that's going to be volume 2, and that'll be volume 3, obviously. And it'll be block 2 and block 3. Block 1 named bushing. Okay, well, let's just get these renamed 2 and 3. Volume 2 is yellow, so I can just click on the yellow and see that that's volume 2, and that one's volume 3. So we'll call this one we'll call the outer core, or outer case, and then volume 3 will be the inner core. And so now I have skipped a bunch of button clicking in the command panel to assign all these blocks. I can hit play, and it plays these commands. I can verify in my model tree that those have been set up properly. And so then I'll just start saving this. I'm going to call this, we'll just call this the live demo, or Endurica live demo. And then I'm going to choose, by default, it'll always save to a .journal file. Just to be specific here, we'll go ahead and even save this for real as a .journal file, or .jou. And then what I'm going to do is focus on meshing each individual piece by itself, or block by itself. So what I'm going to do next is I only want to visualize, or let's prepare, or let's do mesh bushing, which we'll say is block 1. So I'll say volume. Well, one of these I know I can do is I don't want these yellow and purple volumes to be showing up, so I can select both of them and say visibility off. And some of those context commands don't actually then themselves echo, but the commands for that are volume 2, 3, visibility off. It may work if you do it through, I can't remember if it does through here or not. Nope, does not look like it. But those are the commands, is visibility. All right. Next thing that I look at when I see this model is that I can tell I'm going to have, I have quarter symmetry that I can take advantage of. And so for that, what we want to do is we want to cut this body into 8ths and then just keep one section. So we'll do mode geometry, volume, web cut, and then we'll do plane from curve. And let's start by, let's choose, I want to cut this volume using this curve. Oops, let's do this curve, near vertex, and we'll choose this vertex. And I can preview what that cut's going to look like. So I'll hit apply there. Just for this, I want my little triad back here. Now we'll go ahead and let's just say we want to work just for my own personal preference. I want to work in the positive X, positive Z, positive Y octant. So I'll take this volume and cut it. Notice that I selected this yellow line. It can be kind of hard to sometimes small mouse movements get different things, but if you tab, so I'm hitting the tab key on my keyboard, and that cycles what's being selected. So I want maybe that curve, and then I want halfway, oops, we want this volume. I want halfway along that curve's length. Now I've got this volume, and what we can now do is say that we want to cut it by some curve along its halfway point. And then we're going to delete all the volumes except for volume 4. So we could just say delete, delete, delete. And I've got my octant. And again, so now I've done a bunch of commands here. And I know that the last ones I have here are these blocks. So I'm going to go ahead and copy from there down and paste them here. Now I don't need these preview ones anymore. So I can delete the previews. Yeah, that was just a graphics thing. I don't need this draw command. If we just expand this, again, I don't need anything that was a preview. I only want the things that actually did an operation. And this says delete, volume 156. And that's fine. And next, what we'll do is, I mentioned this during the webinar, but we want to try to separate out this fillet from everything else. Sometimes the graphics doesn't re-render quite properly, so there's a little trick to kind of force a redraw by giving it a new angle facet. And what I want to do here is essentially trim out. If we turn on parallel perspective here, is if we can separate this fillet, which we can just chop straight down, we'll have like a section here that's just related to that fillet. So I'm going to create a new curve, and I'm going to create this curve by projecting this outer edge of the fillet onto the planar surface defined by this surface. I could also have picked this surface, really any planar surface that I know is going to be above where this curve is. So now I've got a curve. Again, it's the projection of it. So if I now cut by sweeping that curve, cut this volume with this curve in the 0, -1, 0 direction. Again, from that, there's my Y. That'll cut all the way down and through. That's separated that. I now don't want this curve, so I'll just go ahead and say that I want to delete this curve. And again, I've run some commands here. So the commands I want to copy are, again, from where I started making modifications. So sometimes what I'll do is I'll say this is isolate an octant. And then this is prepare the fillet region. Again, I don't need this preview command. Next, what I want to do is I'd prefer to be able to focus. I mean, I could probably mesh this entire region with the sweep, but again, this fillet is pretty highly localized, and I want to have some control over getting a high quality mesh really in the region of this curvature. So if we draw this volume by itself, we try to ask ourselves, how can I cut off kind of this top portion of the fillet from this region? And, in particular, it's kind of challenging because the fillet moves inwards, it kind of slopes up. So it's not on a plane. So I can't cut with a plane necessarily, or if I do, it'll kind of get a larger region and my mesh will have to grow in height. So let's do something here. Let's, and that may be what we end up with anyways, but I'll have like this. What'll happen if I cut with a plane, I'll have like extra stuff down here. So what we'll do is we will project once again this curve along the fillet's boundary onto this curve, or onto this surface, I should say. And that gets me now an extra curve here. And you can see how that now, because the curve on the front of the fillet also goes up, this curve is kind of following it. So let's minimize this. Let's just show transparency here so that you can see how it's not exact, but it's a lot closer to what that interior curve is doing. Now what I want to do is, in order to trim this off, so one of the challenges, again, that projection does not follow along this surface, because that surface is not actually the projection of this curve, right? Projection, shortest distance. So I've got a little gap here. And what I want to do, the strategy is to make a tool that I can chop with. And so that tool is going to be, I'm going to create a surface that connects. So what I'm going to do is First, I'm going to skin these two curves. Oops, let's draw with add. So I'm going to skin this curve and this curve, which has created now a sheet body. And again, that sheet body doesn't quite reach all the way to the end, but I do have some commands from this. So let's build up our journal file, continue our journal file here. So we last did delete curve 280, got these projections. Okay. Oops. So now what we'll do is we'll go ahead and create vertices. So we're going to try to create triangular surfaces now that we can then themselves, we can build curves that connect and then we can cover the curves. So I need to build a vertex that is on this curve, close to vertex. Let's pick this vertex. I can draw that curve now. Or sorry, that vertex. Let's just double check this curve near this vertex. There we go. Okay, so now I got a free vertex, vertex 175. And now I can create a curve that connects this vertex. So this vertex, I'm using control, holding down the control button to multi-select. Oops, because I don't want to multi-select. I just want to select these two for that curve. When we add that new curve, it does draw this outer volume. So let's set this outer volume also to visibility off. Okay, and now I want to draw this curve, or create that curve. And then I can create a surface from bounding curves. So select those three, and that's now created an additional surface that covers that last little gap. So let's do the same thing on this other. Actually, first, let's go ahead and copy these additional commands. This was here's where we forgot to type in add our vertex. We don't need that command above. We'll grab this one. Again, I don't need the draw command, but that creates one of those triangular surfaces. We'll do it again. We'll create this same. We'll do the same process on this curve, close to this vertex. Apply, create a new curve. Those two vertices, and now these two vertices. Copy these. And then now we'll do that bounding curve. Again, I'm using tab on my keyboard to cycle those different selections. All right, so now if we just draw these three bodies, I now want these to be united into a single object. So I'll go to Volume, Boolean, Unite, and I'll select those three volumes, 8, 9, and 10. Apply. So now I've got just one single volume, body 8, that consists of three surfaces. Something I like to do along the way is figure out when, I've got like some curve, 292, and you know, that curve I used when I was creating this tool. So at this point, I no longer need this curve, and so I can delete this curve. Delete curve 292. Now, I really do need to make sure to put that here. But you know what? Maybe I decide, you know what? It really makes sense. I can really delete that as soon as I've created this skin curve. If I delete that curve, perhaps one of these vertices, though, pulled off of this delete curve. You know, maybe it was one of the bounding vertices. So what I can do is say, all right, well, I've not gone too far. Let me play to this point. And let me see. So I've deleted that free curve. And what do these commands, let's see, create curve near 174. Good, that command still works. So it's good that it looks like we were pulling from just that one body. But I can now just run through and say, okay, do these still work? Yeah, no new errors. Create the surface. Created the surface. Make sure it works on this other side. It probably will. It's got that new vertex. Boom, made the surface. Great. So now I can play this Unite Volume 8, 9, 10. So that was a way where I was able to use journaling to help me kind of reorder some of these commands in a way that maybe makes a little bit more logical sense. And be able to do that in a way that was really quick for me to do it. I didn't have to do a bunch of button clicking. So I'm going to save my journal file. The last thing we want to do for this, to finish this web cut, is we now want to make sure we're in volume web cut tool and say that I want to cut this volume with this body 8, and it's going to delete the tool. And there it is. It's done it. And so notice that if we look at the history, web cut volume 4, tool body 8, and then deletes body 8. So when you do that here. And again, I could throw in more comments here if I wanted to, but that's kind of done that operation. Now notice that because that tool body had 3 surfaces, the resulting volumes are also going to have those 3 surfaces. And that's going to be something that we're going to have to address later, is how to handle this case with this additional CAD curve. You can see even on this blue volume, it has it too. So we will address that later. For now, I'm going to go ahead, just so that you can see more of the screen here, I'm going to move my journal file to a separate screen for the majority of the rest of this. I may pull it back over here and there. So notice that I will be copying and pasting things over into this other journal editor window. But that way we kind of maximize the experience for you to be able to see what's happening. So the next thing we want to do, let's go ahead and we'll do a command here to say, well, we can do volume in block 1. This is one of the reasons why I assigned my blocks initially. Viz on. So I can just turn the visibility on for the block. We also said that we were concerned with this nub region. And so we want to make sure that we prepare the nub region for mesh. So we'll go ahead and do that as well. Actually, maybe before we do that, I want to kind of give some reasoning behind why I've moved on from here. I've just gotten to the point where I can kind of recognize that things will be meshable. But especially when I was first learning, what I would do is I would oftentimes, when I was still working on, say, like this fillet region, is I'd say, okay, I've cut this up. Let me make sure, like, can I mesh this? And so I might have naively tried to, see if this can mesh. I may not have noticed those little extra curves. So I might have been like, oh, well, that's really weird. Why can't I get this to mesh? And I would have maybe come in and, said, okay, well, I got that meshed. And what if I set a sweep mesh on this volume from this source to this target, and I've hit mesh, and it's like, whoa, how could it not mesh this? And that would kind of be my signal to like look at my geometry, and that's like, oh, I see. I've got this extra CAD curve here that I can't fit hexes here. I have to have like a wedge. So, okay. So because I can see that, let's delete our mesh. This is where I'd say I'm going to use compositing. And I notice along this way, I'm not adding this kind of stuff to my journal file yet. I'm just trying to see, like, is this region meshable before I move on somewhere else? And so I would say, let's select these three surfaces, composite them together. Okay. And now I should be able, like, does it mesh now? Let me take this surface and source to that surface. And hey, I got a mesh. Hey, that's a really coarse mesh. So let's delete the mesh here. Let's go to our mesh sizing. Notice I could also have just clicked delete the mesh over here, but so let's pick some approximate sizing. Let's go to a fine mesh. Oops. Maybe not that fine. Something like that. And then click mesh. All right, I got a mesh. I've got some poor quality here, but I know that, again, what can happen, that again, there's that projection. And so the parameter space, right, with splines can oftentimes, especially through projections, not be the same between, physically equivalent between them. So you can oftentimes get like these inverted elements. And so I know that I could probably smooth these if I choose Laplacian and say to include the boundary nodes. And then boom, okay. So it sure looks like I'll be able to mesh this region. And I can myself visualize how if I could mesh that region, oh yeah, I'll probably have to do the same on this surface, where I'll have to composite, but and notice I also have not done my imprint and merge yet. I'm just trying to see, are these individual volumes meshable? And so if I choose apply there and mesh, okay, well, I know I'm going to have that because I've got the swept mesh up above. I'm going to have a mapped mesh on this top surface. Let's go del mesh here. So I know that I'm going to have a mapped mesh at the top on this top surface, right? Yep, it's going to have that same little Jacobian issue. I know that I'll probably mesh that fillet region first and smooth it up there. So it'll likely be that same mesh, but I know that if I've got this mesh, that is definitely sweepable in the negative Y direction. So we can, just to verify this, we can say, yep, I want this swept from there down to here. And I probably don't want that default mode that it chose. So you can see it smoothed this. The default is to automatically smooth that target surface, and I want it to just really, it's just a straight projection down, because again, our cut was we just cut in a Y direction. So let's just try with the extrude mesh portion. Right. Delete the mesh. We wanted to mesh the surface first. So if the surface is meshed, smooth it. Can I then sweep the volume again with that extrude? Oops. This is the source. This is the target. Yep. Okay, so I kind of have an idea now for how I'm going to mesh. I deleted the mesh, which is why this one's gone, but for how I'm going to mesh this kind of fillet region. And so once I kind of have an idea for how I'm going to mesh this, again, this is still discontinuous, but I can see the pieces of the puzzle are coming together. That's when I kind of know, I'm going to go ahead and move on to like the next region. And so in my early days as an FE analyst, I would be very deliberate with making sure I could mesh a region or had an idea for how to mesh it mechanically in this way. Now I just kind of see it now. It's hard to describe. So note that I'm just going to kind of take my standard approach as much as possible from here. I'm not going to take like this, method of verifying manually from here on. Let's just at least show in the GUI here, I can say to delete the mesh. All right, so now let's web cut this nub. Anyway, I've done a lot of things here. I did a compositing that, again, I like to do all my web cuts first and then do composite imprint merge. So I want to recover to the same state that I was at before I took this little sidebar. So again, as opposed to having to like do new and then do all these commands manually, I can just hit play. And it'll play all these commands and get me back to the state I was at when I was saying I'm ready to mesh the nub. So now let's go ahead and mesh the nub. So I'll go back to geometry, volume cut, sheet extended from surface, and let's go ahead and we'll cut. So this volume, this surface. Again, if I preview, I can see. So it extends that surface. It's a cylindrical surface, so it's going to be this cut all the way through. And now I do want to make sure that, I like to have a surface that kind of conforms to how this top surface is bending through, because I want to keep a nice kind of, a mesh that's following the geometry. So I'll do a second of these cuts, this volume now with this spline surface. And so you can see now it'll kind of cut through and keep that kind of conforming there. So we've done that cut. And again, I've got a fillet region here that I want to handle. So let's go ahead and say that we, first we'll do let's just verify. One thing we can verify is what kind of curve is this? If I click on that in my properties page, I can see, it's an arc. That means it's a circle. It's not a spline. So it has a plane that defines it. And especially if I have that, there's another tool I can use. It's called I can use cut with a loop. So let's say we want to create a line. And then I'm going to cut this volume with a loop. Again, preview to see what that will do. Great, so now I've chopped off that top region, and then now I'll do sweep surface, and I want this to sweep all the way through. I want whatever mesh I have at the top, I want to sweep all the way through just to keep nice and good structure. The surface I'll sweep is this surface. And then I want to sweep it again in the negative y direction, 0, -1, 0, through all. And I can preview that. And then the last thing I'll do is oftentimes 180-degree bends can be sometimes somewhat difficult. So I'll do another web cut and plane from curve. I should also mention I am doing more than is necessary or strictly necessary, but I find for folks new to Cubit, I kind of want to just show you a lot of different features of Cubit, but B, I find that if you get good at recognizing how you can do additional cuts, you can kind of see we're actually kind of hex meshing this problem in a way. And the closer you can make your web cuts look like the hex mesh, the more success the hex meshing routines will have. And so I kind of recommend to start by trying to get as close to that as possible, and then you can get away with fewer web cuts as you learn how to hex mesh. All right. And so what I'm just going to do is now I'm just going to check, do these volumes kind of mesh? And so I right clicked, and yeah, that's a really coarse mesh, but let's at least, it did at least mesh them. Right? If I go to a really fine mesh size, yeah, like it meshed it. We're just waiting here for Cubit to respond. Give it a few minutes or seconds. Here we go. That's just kind of with that transparency on that I had. Oh, and it looks like I missed a volume. It was volume 16. So, okay, well, let's go ahead and just update our journal file with these changes. So this is really now where prepare the nub region. And again, these commands started after this delete body 8. So I'm just going to scroll up, see where that last delete body 8 was. There it is. So I'm just going to copy all of these, paste them here. So again, I have these previews that I don't need. And so I did the 2 sheets, and then I created this to make a loop. And then I said, I want to sweep that surface. That was the preview again. And then remember we said that, oh yeah, we don't need this mesh, but we identified, oh, I missed surface, as you can see here, or volume 16. So, oops, before we move on, let's just update our journal file here. Maybe, it's kind of out of order. Let's just say that we want to cut 12, 13, 14, 15, 16, 17. So I've added that 16 in there. And let's save the journal file. Let's play it again. Let's just see if that did what we thought it would do. Yeah, so there we go. We've successfully cut that one little volume. Again, that's one of the good things about about keeping your journal file up to date as you're going. All right. Now what we're going to do is we have to tackle somehow this volume. I'm going to move stuff around this big. So if I think about strategy for this is one of the things that's kind of important to think about. I can't just do a sweep in the negative Y direction or sweep down, because if let's just to show some of this here. So let's say like if these were our sweep surfaces, right? So you might be thinking, oh, like I could mesh this and sweep it down, but hopefully you can see how, if we also mesh this, the hex that would have to be able to fit this it's going to be along this fillet. As I refine, or if I were to refine this more, that top hex is going to get really, really slim and have a really bad angle. Like, just to show this, like think about what the mesh would have to look like. Like what the hex mesh would look like, right? For the hex that shares these two faces, right? Like that is going to be a very poor quality hex. So I can't really sweep along like this fillet. And I have the same issue if I were to say, well, these are the hexes I'm going to sweep down, because then, the hex that would be formed with this element or that face. And if we just mesh this as well, the hex formed by these two faces would also be horrible. So I can't just sweep down. I can't sweep along the radius because again, I've got this cutout. I'm gonna have that same issue of trying to sweep around a bend. And then I've also got like this complex fillet over here. So I can't really work with that. But here's what I see, and you start to see this as you get more experience. I can kind of see that I could chop off a region out here. Like if I could just have these two surfaces, like that looks like a sweep. So it's like if I could mesh part of this face and sweep it along this curve, I could get a hex mesh in this region. And then if I could get kind of, delete our mesh here real quick. If I could kind of get a hex mesh or a surface mesh on this surface, I could then maybe sweep down. Again, I have to watch out that I can't have the mesh come too far up or I'm going to get bad hexes. But if I could cut the mesh off at some location, I could then mesh some portion of this surface and sweep down. And then, just like we saw where I had, if I have a mesh here, some portion of this could be meshed and I could sweep that around. So what I'm kind of seeing that I want to do is to kind of make a cut somewhere along, let's just trying to draw, but I don't have a marker here. But if I could kind of make a cut somewhere along here, that would allow me to do those two separate things where I could mesh this top region by itself with a sweep around, a sweep down, and a separate sweep down. So that's what we're going to try to recover. So to do that, I don't really like this little thin surface because again, if I mesh that, I get really kind of poor quality because again, this like small curve is constraining me. So what I want to do is I want to maybe create a cylindrical cut somewhere that's halfway along this. So let's create this a cylindrical arc. Let's go ahead and create some vertices on curve. So I want a vertex that's maybe halfway along this curve and halfway along this curve. Oops. So at the midpoints. And then I need some third location out here. So to do that, let's create a curve at the midpoint along this. So create a line between these two vertices. And then another vertex here. So now I've got three vertices. And I can do a web cut, a cylinder radius. So cut this volume. Oh, because I don't have a radius. So let's instead do we'll create an arc from three vertices. Vertex 1, vertex 2, vertex 3. It's not a full circle. And now I can sweep that curve also down. So this volume, this curve, 0, -1, 0, preview. So that's the cut that's going to make. Sometimes I'll turn on transparency so I can verify, yep, that's what I want. That's kind of what I want to do. And then I want to clean up, right, these curves that I no longer need. Oh, that's right. We've forgot that curve up there. That's curve 338. So let's do this. Let's delete that curve, delete these two curves, and then delete this vertex. All right, grab my history here. And just to show the journal file, so we did that last really big web cut. That was the 12 through 17. And then we did some things we were showing how we would do a mesh possibly. Okay, here's where we did our operations. Okay, so we'll paste this here. This is really now prepare the outer bushing. Create our vertices. We forgot that was the bad command. Create the two vertices. That creates this helper curve that we can then delete. Don't need the preview. Okay, now this curve 338. We can move that up to where we did this after we did this loop curve. Again, I like to keep things clean. And let's just verify that it will save our journal file if we play to this portion. So that curve has been deleted. That command, those commands still work, and these commands should also still work. I don't have any concern that those work. Perfect. All right. And again, I know that this region is meshable. So, all right. So now the question is how to cut this last little bit. And what I can kind of see is that, all right, I just need to lop off this little top here. I can do this partially by saying, you know, I want to create a vertex on this curve. That is, say, at some point. So let's go ahead. Let's see. Curve. Maybe it's just look. Trying to remember. Oh, by picking. Here we go. Boop. So there, I picked some point. I'm kind of thinking, you know, it might make sense to have it be at some location that's kind of like at that maximum curvature, maybe. So I pick some value and said apply, and I can then, well, actually want to do maybe one thing different. I have a challenge that I've got, you know, this nub here that yeah, so let's maybe actually have, yeah, what I kind of want to do is I want to separate out, like in the general case, for more general robustness, is maybe this nub might move in or out. And so what I kind of want to do is maybe like pick a circle that's, you know, somewhere in between. Well, this might actually be fine. Yeah, let's go. We always know, right? We're going to know that the nub and this fillet aren't going to be at this region of high curvature, so we're probably safe with that. If we then cut the volume plane from curve, this volume, this curve near this vertex. So now I've got a volume. If I look at this volume, right now I no longer have like I can refine this, and it can't, like that angle won't get any worse than this angle. So just to show like what I mean by this, if we do a sweep, actually let's start by just meshing these top surfaces. Right, so at this coarse angle, I've got, you know, this mesh, the angle, it's kind of a large angle. But now as it refines, as this point moves closer and closer, right, that angle actually is going to get less severe. So if I remesh these with a finer mesh, because it's just the nature of this curve as it's coming in, and it's at that maximum, kind of near that max curvature location, the angles actually get better, but they can only get so bad. Because like if I had one element that went from here to there, that would be the worst case in terms of its angle. So I know that I can take a mesh like this, I can refine it as needed, and I'll be able to sweep it down to this bottom surface, right? And at least, you know, these elements are going to at least have some bound where I won't get a inverted or a, you know, potentially a zero Jacobian element. So that's kind of my thought process there. Now, this is still not great, right? I still have like this, you know, this element here, because again, it's a mapped mesh on this surface. And just as an aside, notice that if we delete the mesh, if I could pave this surface, paving would kind of allow me to like not be as constrained, and that might actually be a better element. So now I'm kind of thinking, all right, from like a mesh quality standpoint, you know, if I could even separate this out further where I have some additional region down here that is kind of, you know, this is not for just being able to get a mesh on at all, right? I have something that I can get a mesh on, but now I'm thinking about, like, I'm thinking ahead for mesh quality. I want one more region where I can maybe pave a mesh to kind of handle this a little bit better. And so now on this remaining curve, yeah, so really I've got two curves here that are of interest. I've got this curve and that curve. And if we just like add a vertex that's at their midpoints, you know, so whichever one, you know, I want to make sure that, you know, I don't want to, you know, be too close to, you know, either the nub or this. So I'm clearly pretty safe here. What I can do is I can then go to the vertex selection mode, pick one of these vertices. And I don't really know where the origin is, but if we just like say, give me a vertex at the origin, you know, so I can say, all right, well, in the X, you know, got this, you know, I don't care about the Y's, that's really on the Z, that would be something of a radius of like, call it 28. And this would be a radius of, you know, 27. So, you know, I could pick, you know, 27, or something like that. And be fine. So what I can do is now I can say, okay, let's go ahead and let's do a cylinder surface. Cylinder radius, here we go. Cut this volume with a radius of 27.5. Cut it down the middle. And the axis is the y-axis centered at 0, 0, 0. So I'll do that cut. And so now notice what I've got is I've got this region that can have, you know, a custom kind of pave, or in this case a pick polyhedron, but I could have a mesh here that maybe is better able. Let's pick a better mesh size for this volume. That's maybe better able to get me high quality elements kind of in that little region. And that can itself be swept and then I'm still going to be able to, mesh this top volume and mesh down. And because now I have a less, you know, um, egregious or steep angle, that'll be a better mesh quality, even when it's like a mapped mesh. So you can see how I've essentially cut this to where anywhere I've got a map, the map itself is almost rectilinear, right? You want to try to have, again, that sweep is going to be like along that face will be a mapped mesh, so it'll be rectilinear topology. And so I want the shape to look like it's almost a rectangle. And you can see how that is closer to a rectangle than when it was, when this was the surface. You can see how that wasn't even close really to being a rectangle. So again, not strictly necessary to even get a mesh, but that was just like a mesh quality thing I knew I wanted to just do. So, all right, so now we ran a lot of commands there, right? We did a lot of things. And so what we might want to do is say, all right, this last command, I'll just pull this journal file back over. Our last command here is delete vertex 277. So here's that delete 277. I'll call this prepare the inner region. Anything with meshing, so like the scheme assignment and sizing, I know I don't need any of those right now. So that's a whole bunch of mesh commands I don't need. I don't need this draw command. Here these are just utilities I was trying to do to be able to see that size. For the cylinder radius. So I could do that. So I could get out that 27.5. So I don't need those. And these are more meshing. So there you can see, I did a whole bunch of things when I was trying to explore that. And then I can just kind of simplify out my journal file to something that's really quite simple. Now, a few things, this is kind of gnarly. Don't really like that. Like, why'd you pick that value? And so this is where, I had some logic behind that. I knew I wanted to pick on that curve. I wanted to pick like a region of like that max curvature. So now what we can do is you can't really do anything with Cubit's command language, but Cubit has a Python API that we can switch to. So, so let's go ahead and say that what we want to do is we want to switch over to Python. And we mentioned we have shebangs. So using this text, I can switch to Python. What that probably means is that if I'm going to switch to Python down here, it's important that I switch myself to Cubit maybe at the top if I'm going to be doing a lot of scripting. So whenever I start entering shebangs, I try to block, cover every single kind of language with a shebang. And I know that after I do this, like this is going to be my cut from whatever that point is. I'm going to shebang again back to Python. Sorry, back to Cubit. So I'll put my shebang here to be ready. And now we're going to do Python. Now, when we're doing Python here, what we're going to do is we're going to use the Python documentation for Cubit, Coreform Cubit. And there's various methods-based APIs. So every single command that we've been doing, we can just pass in as a string to Cubit to apply them. And then there's also this object-based API where for different geometric entities like curves and surfaces, there are methods associated with each of those objects. And so you can see I can get the curvature of the curve at a given point. So now I can get the curvature. And I can get positions from, say, like fractions Oftentimes with curves, we have what's called a U parameter, and so I can get like U from position, and then again like the vice versa, position from U. Notice that there's no position from fraction though, so I can get. I guess there is a position from fraction. So that'll work. Okay. So I'm also, by the way, going to use SciPy has optimization routines, documentation, user guide, optimization, and they have like minimize scalar as one of their methods. So I just want to find like a single point along this curve. There's that point I can define as like a fraction of the curve length. So that's a scalar. So all right, I'll use this. Oh, SciPy optimize. Yeah, so okay, that obviously means that I'm going to need to import SciPy. So now I'm running Python here. And at the end of the day, what I'm going to want to do is I want to do this Cubit command. I'm going to use f strings here. And have some curve, and I want this to. I'm not exactly sure, but curve ID equals. I know that's going to be 205. So I can then put in here curve ID. And I'm not even sure why it should be possible to create vertex on curve. Oh yeah. So if I have a position, a very specific position, right, I can then 1, 2, 3. This I think will project possibly, but so I'm changing my curve a little bit. I guess I could also keep this command. So we'll just keep this, but that's going to be an XYZ position. So let's call that XYZ 0, XYZ 2, 1. So I'm going to want something like this. Cubit CMD, another F string here. Actually, I guess I don't really need the F string here because we'll just use the same. We'll move this to the Cubit portion maybe. But I just need to be able to create that vertex programmatically. So if I've got a curve ID, I know in order to get the position, and I kind of want to be able to find some fraction along the curve that I was working with. So I'll have a fraction as my scalar output as opposed to a position because that would not be a scalar. So I want a single scalar. So I can do this, get position from fraction. Okay. So I can do Cubit dot curve, give it the curve ID, which is going to be 205. Pull this over here. Oops. That's right. Cubit takes precedence on the screen. So let's move it to the top corner, this to the bottom corner. Fraction, we want to get the position from fraction and some value fraction. And that'll give us XYZ equals. So then this XYZ will get passed in here. So now I got to figure out how do I get fraction. Okay, well, we mentioned I'm going to use this SciPy dot optimize minimize scalar, and I'm going to have some, I'm just going to put this in brackets for now. I know I'm going to need some function, and then I can give it bounds. Okay, well, it makes sense the bounds of the fraction are going to be 0 and 1. And then I think we can also give it an initial guess. Maybe not, though. All right. This also does mention that what it returns an optimized result, right? I don't care about, maybe I don't care about like the flag messages. I just want to get out like the value. So like it says X is a solution array. So I just want to get out X. And that'll give me the fraction. So the fraction will equal that. So now I just need to define this function. Okay. So we've said that what we want to do is we want to find the location of maximum curvature. So if we have a function, let's say that we want objective function. So maybe we'll call it max curvature objective function. No, it's a long name. But it'll take in we'll have to give it the curve ID to evaluate, and then we'll have to give it the current fraction. And what we'll want to do now is, maybe we want some command that will say get the curvature. Instead of calling this max curvature, we'll call this maximize curvature. And because we want to maximize, right, we'll want to return the inverse of it, right, or the additive inverse. Otherwise, we'll try to get to a small curvature, and a small curvature, again, is like a plane. So we'll want to return this. Okay, so now we need to get the curvature. So let's write a function, def get curvature at fraction. Again, it'll have to take in the curve ID and the fraction. And we can use our utilities here to say, okay, the curve is going to be, just because I'm going to do this a lot, cubit.curve, curve ID. The curvature components will be the curve's curvature at a point. Okay, so curve.curvature, curve, I guess somehow we'll need to fit in the position. So again, I have a fraction, I need to get the position. So how can I get position from fraction? Position from fraction. Okay. So this will be curve, position from fraction, and I'll just feed it the fraction. So it'll be the curvature components. And again, the total curvature will be the Euclidean norm. And I know it, so I'll need a math square root, so I'll need to import math here. Okay, and so let's do the 0 square plus 0 square. All right. And then that's what we'll return. So we'll return the curvature. And so then this becomes curvature equals get curvature at fraction. Now, obviously, you know, this is effectively just a one-liner. Right, just multiply by -1. So we can obviously condense this if we wanted. But the key is that this is now something that I could, like this function is very bespoke to this specific problem. Whereas this function here is something I could reuse maybe on later problems. And so I could put this into like my own little script utilities. So that's going to be why I've kept it separated like that. We don't need this curve ID up here. We need it here. So now we can say what we want to do is we want to make a lambda function yeah, let's call it F for fraction. Maximize curvature, and that's F. So this lambda function here will be evaluated as our objective function. And it will try to minimize the result of this, which again will be maximizing curvature. So like a high curvature value, say like a curvature of 80, will now be -80, which will be lower, so minimized compared to a low curvature of like say 0.2, negative that will be -0.2. So this should get us out what we want here. So let's test this out. Let's play to this stage. Okay, so we're here. This curve is still 205. And now let's first make sure that we have the Python syntax correct. Yep, so no parse errors. And let's just try running this part. Okay, let's see what that fraction is. Okay, 0.25. Position from fraction. XYZ. Okay, and does that kind of make sense? Yeah, we're at the 0 on X, essentially. Okay. Let's create the vertex. Yeah, look at that. That looks to be right about at that location of max curvature. All right, and so that's vertex 286. So now we can say, again, that plane normal this is still curve 265. So if we play this line now, oops, we need to switch, and that should bang back to Cubit. Yeah, look at that. There's our two cuts. And then we can delete that free vertex 286 as well. Delete vertex 286. All right, so let's play all of that all together at once and just see if this works. Hey, look at that. That's pretty nice. All right, so that's that little cut. So now we're pretty much, I mean, if we specify, this is one of the things I oftentimes will do. We'll just say like in block 1, just trying to mesh everything. Oh, right. And I knew that I had those composite, or I know that these two I can mesh with that compositing, but look, like everything else meshes. So now I'm feeling at a pretty good spot, just those 2 volumes, 4 and 11, that I could probably get this thing to hex mesh. All right, so now this is where the stage goes. I've kind of handled getting meshability, and some initial quality things, but we now need to make sure that we can, we need to do the compositing. And I mentioned in the webinar that this curve will, or this small area here will kind of overly constrain my mesh, leading to poor quality. So now we'll do compositing. So we'll go ahead and pull up again my journal script here, and we're now apply compositing. And what I tend to try to do first is composite things that are required for meshing, and then composite things that I know will give me a better quality mesh. So composite the complex fillet for hex meshability. Okay. Draw these 2 volumes. And again, the surfaces we want to composite here, 151, 152, and 150. Okay, so those are composited. Let's composite the surfaces on this volume now. Okay, grab our history. All right. And then we'll composite. These are a separate 1, 2, 3, 4. Composite for hex mesh quality. Okay. All right. Now the next thing we want to do is just, again, we want to imprint and merge. Again, watch the webinar for the discussion about what imprinting and merging does. And because it's so oftentimes done that imprint and merge oftentimes go together, there's even like this, there's like this quick imprint and merge volumes at the same time. You can also do them very separate and very very pointed or a pedantic manner, but we just want to, take all of them that are in block 1. We want to be imprinted and merged. Imprint and merge. And then now we can say, after this, we'll do our meshing. Again, we mentioned we wanted to start, move this back over to the screen. We want to start by trying to mesh the complex fillet regions first. And let's choose, we want to maybe a mesh size of the order of like 1 or something. So, oftentimes the way I'll get an approximate mesh size, or like to get an idea for what I want, is I'll use like this little slider and kind of see, what kind of gets me something that I'm good with. This is a good maybe coarse mesh. Auto factor 6. And if you then click in the properties page after you've assigned your mesh size, it'll tell you, oh yeah, you requested a size of 0.5. So I'll then, again, sometimes I don't like these odd numbers. I'll say, okay, 0.5. And again, we want this surface to be a tri-primitive. Tri-primitive essentially means it looks like a triangle. So topologically it's a triangle, and so then this is a hex mesh that will mesh a topological triangle. So we'll mesh that surface first, and then we'll sweep from here to there. And then we said that we want to apply Laplacian smoothing. Oops. Okay, so I'm just going to copy these commands, paste them in my journal file on this other screen. Actually, just so you can watch. Mesh the fillet. And don't need that. Primitive. That meshes the surface. Kind of had a duplicate of that. And this one was just missing that 11. Okay. Oftentimes what I'll also do is maybe begin, or let's do mesh generation. Reset volume all. I do this because oftentimes you're kind of iterating on the mesh, and reset volume all will delete any meshes. It'll delete any applied meshing schemes, any applied mesh sizes. So it kind of gets you back to the base level. And so I'll oftentimes be like, oh, maybe I want this to be 0.25, and maybe I want this to be on. How does this change things? I can just select up to here and play this part and see how things work. So, and like, oh, if I have a finer mesh scheme, it looks like the Laplacian smoothing might not be enough. So, we might want to specify our tolerance here, maybe to like 1e minus 5 or something. And see if that, for these finer mesh sizes, notice because I've got a tighter tolerance, it is going to take longer to run. I think we can pause this partway through, maybe not. But we can at least get an idea for whether or not, a higher smoothing tolerance will work or not. Almost done. Yeah, all right. That certainly looks like that is gonna work a lot better. Oh, here's that smooth tolerance. All right, so let's take our little command here and paste it here. And again, that kind of took a long time. Maybe we don't need this to be 1e minus 5. What if we just, the default, which by the way, we should always reset the default after we're done applying the smoothing back to the default of 0.05. But, how did that work with 1e minus 2? Well, we can just play and okay, so 1e minus 2 wasn't fine enough. Which kind of makes sense. It's only 5 times finer. 1e minus 3. This is weird. Let's just see. Okay, so even 1e minus 2 looks like it's going to work there. Oh, volume 11 smooth scheme. There we go. Yep, so that's where we can just... But notice we can like kind of now test with these different smooth tolerances. Okay, 1e minus 2 seems like it works pretty well. Let's just look at our mesh quality real quick. Again, I prefer the scale Jacobian when I'm dealing with finite element methods. Yeah, 0.704 is a great mesh. So, you know, you could leave it there. That's pretty good. In my opinion, scale Jacobian is really the best metric for finite elements, at least in solid mechanics, the ones that I typically use. That's kind of what I recommend. Fluids and some other kinds of applications, it may have different needs, but it's a pretty good jack of all trades. All right, so we've got that region meshed. And now we want, you know, this is also kind of that complex region. You know, and we'll want to maybe, you know, make sure that it knows the directions to sweep. Okay. Let's grab those commands. It's going to be after this last. There we go. Copy, paste. And again, because I had this apply scheme before meshing, it duplicated this little part, so I can just delete that part of the mesh. All right, and we'll just verify that, you know, it didn't do anything weird, but we'll just hit apply. Yep, very good. Again, it's a little bit lower quality at the top because through the thickness it's going to be kind of spanning it out. But again, 0.9 is a great mesh quality from a scale Jacobian perspective anyways. All right. Yeah, I'm just worried about meshability right now. I'm not really worried about like the mesh size or the quality too much, as long as it's valid. The next part we want to mesh, again, we said we cared about this nub region. So again, I don't care about anything that's in the bulk. I just care about like this little part up at top. You know, so we might want this to also have that same 0.0 or 0.5 and mesh that. And that was pretty nice. It auto calculated what the mesh scheme was. So when I hit, you know, just apply and mesh, it just picked the auto, right? Automatically calculate, is able to figure it out. So hey, that's pretty nice. I don't have to worry about picking out individual mesh schemes. And then what I might just say is mesh the remain. So there's one quick comment is because, you know, this mesh has now defined how many elements are going to be through the thickness. So it's now going to be dictating, in this case, the rest of this mesh. These two regions combined. But if we had meshed this region, we could have meshed this region with a finer mesh that might, you know, it might not be possible to then recover across. So that can, you know, you wouldn't want to mesh, you know, like this region separately, for instance, like, because we really want to be able to connect them first. Okay, so once we've done that, let's go ahead and, yeah, mesh the rest in block 1. And let's just see if it can auto select. Yep. And again, because we got really large elements next to really small elements, we get some bad element quality there, but everything meshed. Here's our, you know, auto there. And let's even say we want this to also have scheme auto. And we say mesh volume, notice it said delete the mesh and propagate. When we click the mesh, it's like, oh, okay, I'll delete everything in that block and remesh everything. But we really don't need to, there's this extended parsing, so except width is meshed. We really don't want to update anything that's already been meshed. So there we go. And we might want to specify like a mesh size. I am not going to worry about, again, in the webinar, we chose some very specific mesh sizes. The GitHub code, you'll see I've got a little unique way for choosing with Python, being able to choose based on if I want a coarse, medium, or fine mesh, how to choose different mesh sizes. Just for this live demo, we're just going to pick a nice fine mesh. So let's see if this works. Play our script. All right. And again, let's see. Oh, it's because we never specified a mesh size for this one. We want that one. I'm just on my script here on the right. I'm just saying volume 4 size 0.5. And then I just clicked to play on the script again. So you can see how this is really nice that I can do these iterations pretty quickly because I've got my journal file written. Here we go. So there's my mesh. Again, this is a super fine mesh, but we could easily change around our mesh sizes. All right, so now I meshed an octant, but I wanted a full 3D mesh. So what we're going to do now is we're going to create. We're going to copy these volumes by reflections, and copy the meshes. So I go to New, Copy, Transform. In block 1, so all the volumes in block 1, I want to reflect. And, I'm pretty confident that, I'm pretty confident these were centered at 0, I'll show, for one of these, I'll at least show like how you can define your plane. And for maximum robustness, you might want to take that approach. But at least for X, the YZ plane, I can preview, and that's probably the. We even saw that those point locations, right? If we just like pick some points, it's at 0 on X, 0 on X, 0 on X. So 3 points, they're on a plane. And those that have the copy mesh on. Oops, I forgot to in block 1. Okay, and now I want to do the same. Let's go ahead and after this command, we could say. This is probably a good spot to show Python for, I suppose. We can get around this. Again, I want to just be adding these to the blocks. Because I've already got every volume is already assigned to a block, I can say block 1, vol all, except in block 1, 2, 3. So anything that's not already in a block, I can just add to it. And so you can see I'm just adding these volumes. Maybe now I want to reflect, that Z plane. And we'll do that same vol block, except in volume. And then now, maybe now I'm not sure if this is on this plane or not, right? I mean, I know it says 0, but let's just say we didn't exactly know what our plane, or if we could use those planes. We could use a curve to define. And so now if I just pick a curve, I get a little arrow, and if I hit preview, okay, I don't want it to reflect up there. If I reverse it, yeah, it'll reflect down there. And that's another way that you can do this. So we're just doing that. So it's creating those new volumes. And we'll do that same block. Okay, so then we'll just copy these commands, paste them to our journal file. I guess this is meshing the nub. This is mesh the rest of the bushing. And now we're recover the 3D model. Paste. Again, don't need those previews. Okay. And then the last thing I need to do, or want to do, is I still have these if we turn off the mesh here real quick, is I want to make sure that I get these merged again, like those bounding faces. So like if we just show these two volumes here, and if I choose to select by surfaces, so I'm hitting tab, there's two surfaces. So tab once, notice 844, tab again, 520, it's the same location. So we've got two surfaces there before I get to the back end. So I want to merge again. So now I don't want to do an imprint, I just want to say merge the volumes in block 1. And so now it'll just look through all of those volumes that are in this one block and see what it can merge. And that is now connected. Again, because I was doing reflections, right? Those nodes are co-located. Because those nodes were co-located, through that reflection, they're now merged together. And we can say draw block 1. So that is now our mesh, or merged mesh for that bushing. All right. Now, just real quick, as just a matter of, finishing things off, right? We have these other two volumes. These two volumes are pretty straightforward. This volume here, if we draw it, I could get away with just a mini to one sweep. I wonder if Cubit will even recognize how to do it. Yeah, so we can just specify a multi-sweep here. So from those two sources to this target, that should work. Let's do mesh. Might need to. Oops, that's right. So I just deleted the mesh from the bushing as well, but that's okay. We know that we've got that journaled. Let's see if we regularize this volume. Let's just see if we can get these two sources to this target. There we go. And we could even specify, you know, I mean, in the analysis that was done, we just used these as rigid bodies. So as a discrete rigid body. So all we just need is to have a mesh on this. But we could assign different mesh schemes. We could web cut this outer case if we wanted to. And it's a similar story with this volume as well. Looks like we'll need to do the same regularization for this volume. And then we can likely mesh it. So again, I'm not going to spend a lot of time meshing these two. Actually, it might just be good to do it. Let's say that we weren't doing it as a. No, I think it's fair. Probably just leave it here because I think I showed what I really wanted to demonstrate here. Let me just grab though these last few commands to paste in our journal file. So this is mesh outer case, that's block 2. So we regularized it and then meshed it. Mesh inner core, which is block 3. And then we could choose a mesh size, volume 2, size maybe 2. Because again, it's just going to be a rigid body, wall 3, size 2. And we'll just go ahead and once again, just for speed here, graphics tall, angle 15. We'll go ahead and I'm going to play that journal file one last time and make sure at the end that everything looks like what we want. Doing those reflections. Reflecting in on the Y plane. Oh, and I think I forgot to do the final. Yep, I forgot to do the final merge. Sorry, in the merge volume in block 1. So the menu or the progress bar is hidden by this journal file right now. There goes consolidating those. All right, and then ball visible. So it's just, well, at the very end of doing that, we'll say volume all visible. All right, one last time to play through the journal file just to make sure after I added that last little merge command. Doing those 2 reflections, reflect on X, now reflect on Z. And now we're reflecting on that Y axis. And then merge them. Oh, that's right. Volume all visibility on. Visibility on. I'm just going to play these last few commands in from the journal file. Play those. Here we go. And we can just draw these blocks. So again, you can see the full meshed kind of final solution where everything is merged and contiguous. And now the last step we might do is say that we want to bushing mesh, export this to Abacus, and we want just the mesh file only, and we want these 3 blocks to be instanced in this case. So in this case, Enduric needed one of these to be separate instances. I don't have the ability to open these for you, but that's just like one of the advanced options that you might choose that you want to have. And so now we're just writing this out to an abacus.inp file. So, anyways, I hope that you enjoyed this webinar, or sorry, this video. I'll include the journal file as written during this demonstration. I'll include a link in the description of this video, and we'll also link to it through our webinar. I will also provide a more fleshed out, mocked up, cleaned version of this that you may choose to watch or to use as well. But is what I would use going forward. As a last aside, hopefully you can see that because I've used this format, this approach of building up a journal file at the same time as building my mesh, that now if you came to me with a slight modification to this model, so just to close some things down here, if maybe like this nub was moved slightly, or if the radius of like the fillet changed, or its kind of dimensions changed, I've now got a really good starting spot where I could take most of this kind of functionality and like with these blocks, and I could swap out little pieces here and there, update some IDs. I could rewrite this with Python. If I was doing hundreds of bushings a year for simulations, I would actually even extend these out into separate functions that I could then reference more easily. But this first time meshing it took us some time to do setup, but now I can amortize that initial time with a journal file that I can modify for modified geometries. So with that, we'll end this recording.